Hey everybody, welcome to Hank's Donut World for CS135 Assignment 8. I believe this was actually a make-believe donut shop from the movie Overboard. It's an older movie with Kurt Russell and Goldie Hawn. It had mixed reviews, but I enjoyed that movie back in the day. So for this assignment, we're going to, I guess, create this sort of automated menu driven program to allow a user to purchase donuts, I guess is the idea. So let's go ahead and get into some of the details for assignment 8. Okay, so I made a few changes to the PDF from the last cut of this video, and I'll go over that in a second. It's just these arrays, I made some modifications right here in the PDF. Let's first go over our struct donut type. So we're going to have a donut, and each donut will have these fields. So every donut has a name. It'll have a Boolean for its type. Now, a donut can be either a dough-based or cake-based. So the type, if a type contains true, then donut will be a dough-based. If a type contains false, it'll be cake-based. Now, I guess it doesn't really matter as long as you're consistent on that. It can be vice versa. So you can have false be dough-based and true could be cake-based. It's up to you as long as you're consistent with that. Then we'll have the price of our donut, a filling, and then we're going to have two toppings for a donut. So we use as toppings a string array, and the size will be 2. So we're going to need to actually maintain these two arrays because you want to actually maintain a list of donuts that we have currently at the shop that can be purchased. Then we want to have a second array of the donuts that we sold. So you're going to have two arrays you're going to be maintaining. Now I set the max size to be 50 for both. The CSV files you're going to have will not contain more than 50 lines. So again, to avoid using a dynamic array or a vector, we're going to create these arrays of size 50. And then we have these two counters, amount donuts and amount sold donuts. This will tell us how much of these arrays are currently being used. So just to avoid having vectors for the assignment, since we are using this new struct concept in C++, I'd rather just not incorporate vectors into this. So let me go ahead now and discuss the functions you're going to have to implement in this assignment. Okay, so here are the functions. They are not written in any particular order. You can implement them in any order you want to in your program, but this is the order that I constructed here in the PDF. So our first function, getFileStream, we're going to pass in some prompt message, for our MSG parameter. This function is going to prompt and read in a file name. It will attempt to open a file stream. If it can't open it because the file name is not valid, the function internally will keep reprompting. And once we have a valid file name, so the file stream was openable, we're going to then return that working file stream back to main. Then we have our function getDonuts. This is going to be the more heftier function you're going to have to write. This function, you pass in a working file stream, and you pass in an array of donuts. And you're going to then, using the int file that's passed in, you're going to read your CSV file, and you will populate your donuts array, sort of one line at a time from your file. You're going to populate each element of your donuts array one by one. Then at the end, you're going to return, as an integer, you're going to return the amount of lines that were read from the file. I'll probably go into this function in a bit more detail later in the video, but I'm just doing a very quick rundown of everything in this PDF. Then we have our other functions, continue menu. So remember, we want to ask the user if they wish to continue. So basically what's going to happen is you pass them prompt message and the user has to enter a string. If they don't enter yes or no, you have to reprompt. And then of course, once they enter yes or no, return true or false. Now in this PDF, I had it where it returns false if they enter yes, because in our program, we're going to ask them if this will complete their order. So yes means that yes, it completes their order, so the program would then stop. But again, It's up to you how you do this, as long as in main you're consistent with the return of this or whatever Boolean is returned by continue menu. But a prompt message outputs a message, and you have to read in a string. And of course, make your input case insensitive. So they could, of course, enter capital Y, lowercase e, capital S. That has to be interpreted as yes. You have to make sure that it's case insensitive. Now, there's also a function I'm going to go over in a little bit that's going to be used to work around case insensitivity. But of course, once you enter yes or no, return true or false accordingly. Then sort by price. Well, we're going to pass in the donuts array. Now, in this function, we're going to be probably passing in the sold donuts into this function. But right now, we're passing reference in. So donuts in this particular instance is going to represent the sold donuts. And same thing, the amount of donuts will be the amount of sold donuts. I didn't really modify this in my PDF. I made this function generic. But anyway, we're going to pass in a donuts amount, or donuts array, sorry, and a donuts amount. And then we're going to have to sort it in ascending order by price. So you can, of course, just copy and paste or Google the bubble sort code, because really it's a known sorting algorithm, and we went over this in class. So you can, of course, use that and apply it to the to this struct array. And then we have our function search by name. Well, we're passing in a donuts array, an amount of donuts, and a name. Now, you might notice, what is this whole const in front of this donut type array? Well, all that really means is that the const in front, so remember, if you pass an array into a function, it's always passed by reference. So the const in front of the array name is going to not allow you to overwrite anything in the array, which makes sense because really this function is going to just simply search the array for the donut name contained in this name parameter. So we're not going to really update anything in this array. So having a const in front is just a lock to make sure that nobody can overwrite. This function, search by name, cannot overwrite anything inside a donuts array. So again, you got to make sure it's case insensitive. So you have to make sure that you're able to search for name correctly in donuts by making sure you handle the case insensitivity, which I'll go over that in a little bit. But anyway, this function returns the index where a name was matched. So if you found this name in your donuts array, return the index of where you found it. If you did not find this name in this donuts array, return -1, which implies back in main that, okay, this name was not found in this donuts array. Now for the int get cheapest donut, this is going to be the equivalent to your find min function that you might have learned earlier in the semester. Again, we're passing the array by reference, but a const in front means because we're not going to overwrite anything in the donuts array. We're going to find a donut with the smallest price and return the index of that donut with the smallest price value. Then we have this removeDonutFromList. So the way this function is going to be handled is, well, as we buy donuts, we're going to remove that donut from our donuts array, and we're going to be adding it into our sold donuts array. So you want to actually remove that donut from this array, essentially, is we have to collapse the array. So I'm going to go ahead and kind of just give you an idea of what I mean by collapse the array later in the video, but we're going to remove that donut from the array. So if vectors were allowed, this would be a lot easier to do. There actually is a function in vectors that you can use to erase or remove certain elements from a vector. So using an array makes it a bit more challenging, but I guess it's better for the learning outcome, I suppose, is the answer there. But I'll go over that in a little bit. And then void output sold donuts. This is going to essentially be used at the very end of your program to output the donuts, the sold donuts, to a CSV file, which I guess I will talk about this one a little bit as well later in the video. Now here we go. String all caps. This function, we pass in a string variable, s, and we're going to return s in all capital letters form. So all caps can be used in different functions in your program to make your code case insensitive. So for example, like in the continue menu function, the user you'll read in some string value, let's say no. You can of course take that variable that's read in this function body and pass that into all caps, and then it's going to return back that string all capital. So that way then now you can make your program very easily case insensitive. So all caps will just simply do a very simple function. And then void display available donuts. We pass in donuts array. The amount of donuts is going to be used just to output the donuts to the screen. So it's going to output essentially a donut name and its price to the screen. So this is going to be used in your menu. Okay, so I'm going to go ahead and talk about some of the functions that are a little bit more heftier. I'm going to go into this in a little bit of detail right now before I go into how these functions are going to be used in main in the contents of main section. Okay, so before I get into the GetDonuts function, I first want to go over the spreadsheet files you're going to be given for you to read through and populate your donuts array. So there's really two spreadsheets given, one large one and one small one. The small one will be only used in a final test case on CodeGrade just to test out the case where when every donut has been sold and the program has to automatically stop at that point. The menu stops when there's no more donuts left. So let's go ahead and just show you the donuts file. Unfortunately, Microsoft Excel was not able to show in dark themes, so here comes a bright light flash warning. So there we are. So you're going to read from this spreadsheet. So you can see here each line. My mouse is definitely messed up. My bad there. It keeps on double clicking my mouse when I single click. So I have to get a new mouse at some point. Hopefully it's not going to affect the video. I'm not going to rage during the video and get mad. This has been driving me a little bit crazy the last couple of weeks of this. Anyway, so you can see here every line of this spreadsheet file contains one record. So I'm hoping that you've been exposed to read in a spreadsheet. But if you haven't been, or I guess whenever I first talk about spreadsheet files, I always make the joke that, well, this is definitely way different from a regular TXT file. I mean, look at this. Look how fancy it's got these lines here, and look at all that stuff right there. I mean, there's no way we can read a spreadsheet in C++ without some type of library that can allow us to read a spreadsheet, right? Well, we'll see about that. Now let's go ahead and show you the other spreadsheet file as well. On the wide saying save. Oh yeah, I think I might have moved the columns around a little bit or widened the columns out. The other one you're given is just the same thing except a smaller file. So it was easier for me to construct the input for a smaller file. So I didn't want to spend all day creating the input files for the large ones. This is going to be just for a final test case on CodeGrade for the case where once we sell all of these donuts, then clearly we want to end the program. Okay, so we can see here if I were to close these, let's look at the first one. Oh, such a nice bright, the dark theme is here now, but let's go back to so I'm gonna open this up in Notepad and of course enjoy the light theme once again. But let's look at this donuts file right here. If I right click and I edit, you can see here, well, it's just really comma separated plain text. That's all it is. It's just data on a line, and a comma is used to separate each column of a spreadsheet. So if you see this is actually really not that fancy. It's not intimidating at all. You can just, of course, can read each line and use string functions to separate each line into individual components, which can be then stored into different fields of your donut type array. So let's go ahead and now talk about how do we actually take this file, how do we actually parse it and break it apart, comma separated, and store into our struct array. Okay, so consider this input right here. I just copied my favorite two donuts that are on the list. Of course, my favorite donut is the jelly donut, and of course, the mighty jelly donut does have a nice flair to it. And the jelly jiggler just sounded funny, so I copied that down as well. I guess I could be like a true YouTuber right now and just go ahead and comment below your favorite donut. So anyway, right here, when I say get line in file line, it will read the entire line. So that first line right there is going to read it into your string line. So you have to store you have to break the string apart into individual components and then put it into your donuts array. So if I were to go ahead and do this, so what I could do is, let's say for our donuts array, I think I call it donuts. Okay, so donuts. Now index, I use 0 right now, but you're going to be using the actual AMT donuts. So initially you're going to pass in the value 0. So maybe I'll put that here instead. So you would use that counter AMT donuts. Oops, I think I didn't spell donuts correctly. Donuts, which initially is going to be 0. And then dot name. I want to store the Mighty Jelly Donut into the name field. So what I can do is I can take line dot substra, which is substring, from index 0. And I want to go ahead and go up to line dot find, and then in double quotes, that comma symbol, like that. So what it's going to do is this substring function will give us a substring from index 0, and the length will be, well, this line.find is going to find the index of where the comma was found, which is right here. And that's going to be the actual length of that string from 0 up to, or from 0 to right before the comma. So then what's going to happen is this is going to actually return the Mighty Jelly Donut gets returned and stored into the name field. So I'll put this here. The Mighty Jelly Donut. That's going to get stored into donuts at index, well, whatever amount donuts index contains. So initially it's going to be 0. We're going to store that substring into the name field. Now, we want to, of course, now you want to go ahead and take, well, you want to take this donuts array at amount donuts dot type. Well, it's going to be true or false based on whether this is a dough or whether it's cake. So what we want to do, before I even do this, well, you want to go ahead and we just want to simply extract this word dough. The simplest way to do this is, by showing in class, is we can say line dot erase from index 0. We want to erase up to line dot find, double quotes, comma symbol, ending quotes, +1. So you want to remove the string from index 0, and then this find will give us the length up to the comma, and then +1, you want to remove the comma as well. So this is going to remove the entire string and the comma symbol as well. So now the first character in line from now on is going to be, well, the letter D for dough. So now I can, of course, just simply do the following. So I can just say something like donuts at index amount donuts dot type. I'm going to store it with, I'm going to write type a little nicer actually first. I'm going to store it with the following. I'm going to say line dot substring 0 line dot find. I'm going to have to actually two-line this, equals dough. Now I'm going to semicolon right there. So we're going to take this substring. This is going to essentially extract the word dough or cake. We're going to compare it to the string dough. If this does equal dough, this equals is going to evaluate this to the value of true. and it will store true into this Boolean type. Now, if this substring that we extract right here gives us the string cake, well, cake equals dough would be false. It's going to be evaluated to false, and it will store false into this type variable, into this variable called type, or this field, sorry, called type within our donut struct. Okay, erase too much right there. There we go. So again, we have to continue this for everything in this line. So the next statement, you want to remove the word dough. So again, all we have to do is copy and paste. But I'll write this out though. It's really a nice smooth surface to write on here on this XP pen writing pad. So it does feel nice to write on this. So writing on paper almost, but better than paper. So then we have line dot find comma symbol +1 is going to remove the word dough from the string and the comma. And now the next element, so now strawberry will be, so index 0 of line from now on will contain letter S for strawberry. We want to extract strawberry and store it into the filling field. So let me just do one more example, but you see the point. It's really just a lot of copy and paste actually. So then we're going to say donuts index amount donuts dot filling. Well, we're going to simply just store line dot substra 0 line dot find double quotes comma symbol like that. And now it's going to store strawberry into the filling field of this donut object. So we just kind of constantly interchange these two lines. We first extract the string, a part of the string, then erase. Extract, erase. Extract, erase. We do this several times. Every line has the same number of fields. So you can, of course, just hard code this because, well, you have to hard code it for each line, but then you want to, of course, wrap all that code around in a major while loop. Or not, so, well, it's going to be just a while loop that's going to wrap around this code. So you're going to do all of this for each field in the spreadsheet file, and then increment amount donuts by 1, and then have a while loop that reads the next line of the input file and does this exact same thing, except now amount donuts will be a different value. So it's going to store it to the next index and so on and so forth. Then eventually, once you hit end of file, you of course return amount donuts counter back to main, and it will know exactly how many donuts were read from the file. So that's really how the GetDonuts function, how it works. Let's get on to the next function in this list. So I think there's one more function I have that's a little bit tricky, so I'll go over the next one right now. Okay, so the next function, is going to be the removeFromList. So I'm going to go over an example that's going to be very easily transformable into this struct array. Let me go ahead and just cover a regular integer array for right now, but really you might think that, oh, well, integer arrays and an struct array is going to be way different. It's not the same exact thing. Well, I guess to quote Yoda from Empire Strikes Back, when Luke was trying to lift rocks on Dagobah system, and he wasn't able to lift the X-Wing from the swamp, and Yoda said to him, no, it's no different lifting an X-Wing versus lifting rocks. It's just only in your mind is it different. So same idea here. So I'm going to use an integer array to show this, but really this can be very easily transferable to a struct array, because remember, the assignment operator will work for custom types as long as the two objects are the same. So let me go ahead and just quickly write an array for you over here. So ARR, I'll put a few elements in here. Okay, so here we are. So it's going to be our array. So you can, as you can imagine, we have 1, 2, 3, 4, 5, 6, 7 elements. Let me go ahead and sort of draw the array like this. Let me try to actually do it to scale. So 1, 2, 3, 4, 5, 6, and 7. Perfect. So then we have the following elements. So 3, 7, 2, 5, 8, 10, and 13. I'll maintain a variable. So int, I guess I'll call this s equals 7. So 7 will tell us how many elements we're using up in this array so far. And these numbers here in green below is going to be the indices. So suppose I want to remove the value 5 from this array. So the first thing I have to do is I have to find which index is where 5 is located. So if I were to do a find function and pass in an array or a struct array, remember we had that one function that will find a donut or find the min, it returns an index, correct? It tells us the index of the donut that we found. So suppose you want to find 5. Well, of course, we're going to have an index, which I'll put here, int index, and it's going to contain, let's say, 3, because index 3 is where we found 5. Okay, so the result of this is once you found the location, I want to remove 5, what we have to do is the following. Well, we're going to have to, of course, go through our array. So starting from index 3, I'm going to go ahead and take the neighbor, which is 8. I'm going to overwrite 5 with 8. I'll use red actually instead. And then overwrite 8 with 10. Overwrite 10 with 13. And then we stop right there. And we decrement our size by 1 to make it 6. Now, of course, if you want, you could clear this out as well if you wanted to. But the idea is we collapse the array. So we have 5. We essentially took all the elements after 5 and just one by one overwrote with the neighbor element. And we collapse the array. We decrement our size by 1. So now we only have 6 elements that are currently being used. Anything beyond index 5. So if our array contains, let's say we have 6 elements in use, then between 0 through 5 is going to be 6 total elements. Anything beyond index 5 is going to be considered garbage. So that's how you remove. We just simply use that simple loop to just overwrite the value with its neighbor. Then we decrement that counter amount donuts, or in this case s, by 1. And of course, we collapse the array by that value. So this can be very easily transferred into this struct array concept as well. But I'll let you kind of figure that part out. So now it's time to go over the contents of main. And I'll do some example sort of run through as well, so you can kind of get an idea of how to test out your code. Let's get into the contents of main next. So in this portion of the PDF, I essentially give you really nice step-by-step sort of process for how you want to write your code. You have to, of course, translate this into C++ code, but anytime where I have you go back to step 13 and step 4 and all that, you can think of it as a loop. Let me go ahead and sort of just read this out to you and give you some tips here before I go into actual run, how you can run this code on your terminal. So the first thing we'll do in our program is we're going to just call the function getFileStream. We pass in this parameter, this string literal. That function will go through and it will return back to us a ifstream variable, which we're going to assign that to some ifstream variable defined in main. So we just store it. So we just use assignment operator to assign this result of this function into an ifstream variable. Then we're going to go ahead and call the function getDonuts. We pass in the int file, which we read in the step above, and that donuts array is passed in. That function will go through and read your CSV file, and it returns the value, and we're going to store that value into some variable we define in the file amount donuts. Then, of course, we're going to output to the screen, welcome to Hank's Donut World. So you can copy that. We then call the function display available donuts. We pass in our donuts and our amount of donuts in. It's going to output everything in that. It's going to output the name and the price to the screen for every donut. We ask the user enter a donut name or cheapest. So if the user enters a string cheapest, and of course case insensitive, then just call the function getCheapestDonut, pass in donuts, amount donuts. Otherwise, we're going to call, they didn't type in cheapest, they actually typed in some donut name. We call search by name, pass in the donuts array, the amount, and the name that was entered. And then in either case, these two functions, so getCheapestDonut and search by name, return some integer back to us. We're going to store that into some integer variable we're going to define in main. Then, in step 7, if the integer value is -1, that means we couldn't find that donut. We output not found, and then go back to step 4. So you can see a loop happening here. Or it could be a continue statement happening. It's up to you how you set this up. But we go back to the beginning, back to the start of the loop. Now, if it's not -1, well then, next step, we output donut name. So since we know the index, we can easily just go to that index and access the name field of that donut, output that donut name, and excellent choice. Then we're going to get that donut price, and we're going to add that to some running sum. And then we're going to insert that donut that the user selected. We're going to take that donut, so we know the index of where it was stored. We're going to take that donut, we're going to store it into our other array, into our sold donuts array. So as we buy donuts, we are essentially going to shrink our donuts array by 1, and we're going to increment our sold donuts array by 1 each time. So we decrement from 1, so we take a donut from one array, and we're going to store it to a different array, into our sold donuts array. So we're going to have these two arrays going on. And then we're going to call the function removeDonutsFromList. We pass in our donuts, our amount, and we're going to pass in that index that we extracted in step 6 to simply collapse that array. So essentially, that donut in this donuts array is now removed, but we did store it into our sold donuts array. Then we call the function continue menu. This is going to complete the order. If they say yes, so obviously this function returns true or false, correct? So based on what it returns, if they don't want to continue, we jump to the next step. Actually, I made a mistake. Hold on. So we do here actually, sorry. So I guess this step here, if they don't want to complete, they want to stop right here, then we're going to jump to step 13. I think I have it written right here. Okay, never mind. I got myself confused. So if they want to stop, jump to step 13. Otherwise, if they want to continue, go to step 12, and you have to first check if there are any donuts available. So that amount donuts variable tells us that if there are any available, okay, then go to step 4, back to the beginning of the menu. If there are no donuts available, go to step 13. So there's two ways to end this loop. If the user decides that this will in fact complete their order, or if there's no more donuts left, there's two ways we stop that loop. Step 13, we're going to sort the sold donuts by price. And then we're going to go ahead and we're going to declare an output file stream variable, literally called sold.csv. We're going to output sold, comma, followed by the running total. And then we're going to call output sold donuts, which is going to output all of our donuts that we sold, and we'll output it into a CSV. So all you have to do is you output each field, and then we have to output a comma character in between. That way, that's how comma separated files are stored. So you have to simply output the name, the type, the filling for each sold donut, but we have to, of course, output a comma in between each field. So that's sort of the contents of main. Let's go ahead and now just go over a quick test run of how your program should work. Okay, so this is going to be a main.cvp file I will provide for you. So I have all the libraries included, the constants, the struct, here's your function prototypes. Now here's your main. Now, of course, you can have additional variables as needed, but here's the ones I just used in mine. And of course, you're going to have all your code written over here. And here are all the functions set up for you. So you have to just simply fill in the blanks. I do add a few things here for you just to make things a little easier. So for the amount output sold donuts, you want to apply the set precision. This outputs that top heading. And of course, you have to write your code here to go through the list to output everything. So this will be given to you as help. Okay, so now what I want to do is go into the actual execution of this program. So let's go ahead and check that out. So here's sort of the terminal right here. I'm going to go ahead and actually open up. So here's one of the input files that I have provided for you. So this is going to be what I'm going to use to test out your code on CodeGrade. Let me open this up. I think it's sort of blocking the view a little bit. No, it's still actually visible. Okay, cool. So I'm going to be using this for one of the test cases. So if I run this program, of course, I can just run it like this. And I'm going to pass in the first input. So donuts.csv. And this is going to output all the donuts with their prices. Now I could have actually columned it using setW and iomanip, but I decided not to because I think we all just want to stop with iomanip. So set precision is okay, but setW left and right is really terrifying. So I'd rather just sort of avoid that. So it won't be as nice looking for the output, but I think at this point in the semester, we can appreciate that we don't have to worry about that. So here's the ones we have left over. I'm going to enter. So for my input file, we have Nutella Nirvana. It found it in the list. You selected Nutella Nirvana. Excellent choice. Let's complete the order. I'm going to type in no next. And it's going to output everything again. And I believe there is no more Nutella Nirvana. So this donut, let me see, where was it in the original array? It was right after Cookie Monster. Okay, so let's see. There, so it's not there anymore. It got collapsed. It got removed from this array. But it actually is stored in my other sold donuts array. But anyway, we're going to continue because we didn't want to end it. We still have donuts available. So I'm going to type in cheapest, which is what is given here in the input file. And it found the cheapest one was peanut butter and jelly delight. So that's the cheapest one. Excellent choice. I'm going to say no, does not complete the order. And then now for this next donut name, the buttered barnacle. I don't think that was even a donut from SpongeBob, but I don't know why. I just thought that item at the Krusty Krab, the buttered barnacle, was so funny sounding, so I wanted to use that here with the testing. So I'm trying to laugh as I type this out. The buttered barnacle. We should stop talking for right now so I can stop. I'm trying to laugh right now as I'm typing this out. And then clearly donut not found. So did not find that donut. So then it just lists out donuts again. So it gives us the menu once more. Okay, cool. So I'm going to type in Rocky Roadster. Rocky Roadster. And it found it. Excellent choice. I'm going to say yes, so complete my order. And the program now stops. So this is going to be the results. Let's go ahead and actually pull up in my program here. There should be a spreadsheet file called sold.csv. Let me go ahead and open that up. Bright light flash warning coming up. And these are donuts that we actually bought. So these were maintained in my other sold array. I first sorted them by price. So you can see that the cheapest one's at the very top, then Nutella Nirvana and Rocky Roadster. And in the spreadsheet file, you have to, in your main, actually, before you call the function output sold donuts, you have to first output sold, comma, the actual running total, and L. And then in the actual function you call, I provide you with this heading. And of course, you have to generate the code that's going to output all of these. Each donuts in that sold donuts array, you output each field, comma, like that to create this. To create that. Now, another thing you can do, so let me just show you the other input file provided for you. So let me see, I think it's input 2 maybe? Let's see. That one's pretty big, but let's look at the other one we have. I think I have input 3. So this one's kind of let me see, is input 4 bigger? Okay, no, input 3 is bigger, okay. So this one's a bit of a heftier program. A heftier input, I should say. So what you could do is, of course, you could actually take this and one by one type into your editor or into your terminal as you run your code. But a trick you can do, though, however, I'm going to first clear this out. You could say /a.out. Now, we haven't really covered this, or I don't know, I didn't cover in my section this semester, about Linux redirection. So right here, instead of just typing out all these one by one, I can just feed these inputs into my program. So then cin is going to automatically read from this file rather than having me type out everything. So let's go ahead and try this out. I'm going to say input03.txt. And actually, it just automatically feeds the input in. Automatically. I didn't have to interactively type it, it just fed the input in. Now, let's take a look at this for a second. There we go. So notice right here, enter donut file. Well, there's nothing there. Look. Now here in the input file, input 03, I have a donuts.csv, but it's not displaying here. And the reason why is because I didn't actually type it there. It was automatically fed in from this file. So then it outputs all of this. And then I type in glazed and confused. That was read in. And you can see here it outputs you selected glazed and confused. So you can use this technique instead of actually typing out the inputs one by one. Of course, if you want to type out and test out certain components, of course, but it's actually a nice shortcut. Instead of typing out the inputs, just feed it in automatically into your program. So every time a cin occurs, it's going to read it from this file instead of from the input. And in fact, on CodeGrade, actually, that's how it works. It actually reads your input using these Linux redirections. It's not going to actually manually send the input. It gets redirected from this file, from input that's provided in CodeGrade, and that's why we look at the output, it doesn't actually show what you would have typed in because, well, the input is actually redirected, not CodeGrade is not going to actually manually enter, although CodeGrade could do that, but it doesn't. So there we go. So you can use this technique to test out your code easier than typing all this stuff out. So these input files I provide for you are actually the same ones that are going to be used on CodeGrade. So again, that's just simply how this would work. So nothing too surprising there. So let's go ahead and do some final remarks for the assignment. And then of course we can end this video. Okay, so for the sake of making this PDF a little bit shorter, I'm not going to provide any output on the PDF, but I will provide you with the output in a TXT file on Canvas. So I'm going to provide you with the interactive output as if, let's say, if I were to type the input in manually, I'll provide that output. And I'll also provide the output that was generated by Linux redirection as well. So you have two different types of outputs you can test with. So you can look at the interactive output and redirected output. Now, for specifications, of course, implement the functions provided. Now, do not use string stream to parse each line of the spreadsheet. So it's a very funky library in C++, and you want to actually learn how to do it the more universal type way. Now, unfortunately, there isn't a .split function for strings in C++, but still, we don't want to use any really weird string stream stuff. And also for getLine, we could use getLine up to a comma, but again, we want to avoid doing that weird stuff. So use the technique that I went over in the video earlier. Of course, always document your code. And another, not really, it's more just kind of for you. So for any input in this program, whenever you're going to read any kind of input, use getLine. Do not use, so right here, we've done cin and then the extraction operator, string variable. Avoid using this. Do getLine for everything because The issue is some of the donut names has space in the actual name. So this technique, getLine cin, comma, string variable, will read everything up to the enter character whenever you type in input into the console. So for all input, use getLine. Do not use the cin with the extraction operator. So I have all of that. So I guess that's it for the video. So I guess happy coding and till next time.